Able to interact with the qubits, so the ion trap, the ytterbium 171, the lasers that basically make everything move, apply like the basic interactions. So one of the key things to having an ion trap and having a functional quantum computer is you kind of want those ions to talk.
I want to do a CNOT gate on these two qubits. What does that mean in terms of the ions? So what it does is it looks up what a CNOT would mean in terms of which lasers we have to turn on and when. It then goes through a cycle of making sure the ions are there and making sure they have been cooled because sort of naturally when they're just sitting in the trap, because there's electric field noise around them, they tend to start moving really quickly, which is basically they have higher temperature. So before we do any experiments where we're actually trying to do a quantum algorithm, we first cool them, and then we automatically turn all of the lasers on to create those gates, and then it also automatically turns on the last laser, which we use to read out the quantum state, and then it returns that information to the same computer that we used to program it, and we look at the result. Our quantum computer is one of the oldest in the world. There's like maybe 2 or 3 that are older, and so it runs on really, really slow software. Another consideration for that is that every time we do an operation, for example, just like a bit flip takes like 5 microseconds, and then an entangling operation takes 250 microseconds. So, like, for any of you who understand how classical computers work, you realize you could do many, many, many operations in the amount of time it takes us to do one single quantum operation. So the idea would be that you have to really densely pack information into a quantum algorithm in order for it to be helpful, because running it generally takes longer than just running a lot of operations on a classical computer. So what that means is that in the short run, a quantum computer is not going to beat a classical computer. What you really have to do is find a problem where the amount of information density that you can put on a quantum computer is so much greater than that you can put on a classical computer, that even though your quantum computer generally runs slower, you still have an overall time advantage. But yeah, you do also have to implement the fact that you have to talk to the ions, and you have to tell them to generate these laser pulses. There is actually a bit of a joke in the community that it's possible that quantum computers in the future will need a quantum computer to program them. So that it's a joke, but it's actually based in some amount of reality.